You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome in. You know, if you're currently working in the engineering world, it feels like keeping up isn't just about catching up anymore.
Oh, not at all. It's more like trying to sprint across a constantly shifting landscape.
Exactly. The entire software stack, from your database all the way to deployment, is just,
Yeah,
it's fundamentally changing.
it's true. Architectural shifts that used to take years are now happening in, a matter of quarters.
Hmm.
And I guess that's really our mission today. We're trying to sort through all of that flux for you.
Yeah, our goal is to give you the essential insights you need to understand what's truly moving the needle right now. We're going from, the stunning performance of new AI agents right down to the nitty-gritty of keeping massive systems from crashing and burning.
So let's jump in. How are modern teams choosing their stacks to build faster and stronger?
Okay, let's start with a really surprising choice. Vercel, a company that is, all in on the web stack, built their first native iOS app for their V0 service.
Right.
And they chose React Native with Expo.
Yeah, that turned a lot of heads.
It's a fascinating decision because for years, the narrative around React Native was, it was one of compromise, right? Fine for simple apps, but a total pain for anything that needed real native polish.
Especially interaction-heavy components, yeah.
But V0 is all about a delightful AI chat experience. So how did they pull it off? How did they get past those old limitations?
Well, I think it just speaks volumes about how mature the React Native ecosystem has become. I mean, they faced all the classic headaches.
Like what?
Reliable keyboard handling,
Yeah.
getting that buttery smooth scroll in a really long list, managing streaming content correctly. The key was just pure craftsmanship.
Okay, so what does that mean in practice?
It means they were using highly composable code, custom hooks, and this is the critical part. When the built-in stuff wasn't enough, they did strategic native code patching.
And what did that native code patching actually involve?
You had pulling in specialized high-performance libraries.
Yeah.
They used tools like Legend List for the really complex performant lists, and React Native keyboard controller.
Because the standard keyboard management is just clunky.
It's awful. It often breaks down when you're managing chat inputs that have to dynamically adjust the viewport. Their success really proves that a web-centric stack can deliver a polished native experience if you're willing to use the right tools.
And of course, that beautiful architecture has to scale. Which, speaking of systems working hard, the numbers coming out of some recent infrastructure testing are pretty illuminating. Load testing a Java REST API on a single media machine showed it could handle, between 500 and 1,000 HTTP requests per second?
500 to 1,000 RPS,
Yeah.
reliably. And a large machine sustained an impressive 2 to 3,000.
Those are the benchmarks you need to know what you're really working with.
Absolutely. Those numbers are sort of the ceiling, but the real sustainable efficiency gains, they often come not from better silicon, but from a better process.
Which brings us to Fix-It Weeks.
The scheduled pause button for quality control. I've always been curious if that really works or if it just creates a panic cycle. The evidence says it works spectacularly well, but you have to execute it correctly.
So it's when the whole team just stops all roadmap work.
All of it. No new features. You just focus on accumulated small bugs, tech debt, and quality of life issues. There was one example where 40 engineers paused for 1 week and fixed 189 bugs.
Wow, that's substantial. But doesn't pausing all that momentum destabilize things?
The benefits seem to outweigh that risk as long as it's planned. The improvement isn't just in the product quality, it's in developer productivity.
Right.
When the team isn't stepping over known bugs every single day, they work faster and morale just shoots up. It's foundational. It's a bit like Shopify's prep for Black Friday, Cyber Monday.
Oh, with their fire drills.
Exactly. Simulating 150% of the previous year's peak traffic and running chaos engineering exercises they call game days.
Yeah.
You have to stress the system.
And to stress those systems without, melting your laptop by running 23 microservices.
Which turns your desk into a furnace, yeah.
People are turning to tools like Signodot.
That's a key piece of the puzzle. Signodot lets you run on-demand Kubernetes sandboxes locally. So instead of a tiny, inaccurate mock of your production environment, you get a fully replicated live cloud environment right where you work.
So you're validating against the actual stack?
The actual stack.
Yeah.
You avoid those brittle mocks, and your changes work in the real world before they even get close to production.
Okay, so from infrastructure, let's pivot a bit to front-end craftsmanship. The code we actually ship. A major win for developer quality of life has finally arrived. CSS subgrid.
Oh, this is a huge, huge win. I mean, for anyone building complex design systems, for years, if you use CSS Grid, any component nested inside a grid item was just isolated. It couldn't see the parent grid's tracks.
Right, so if you wanted things to align perfectly, you were stuck doing complicated math or just breaking your markup.
Exactly. CSS Subgrid completely changes that. It lets the nested container extend its layout and participate directly in the parent grid.
So it solves those decades-old alignment issues.
Decades-old issues, yeah. You get cleaner, more semantic markup. It just significantly reduces the complexity.
That's a practical win. Now, for something a user actually sees, performance. We talk a lot about the web animation performance tier list. What is the secret sauce for a buttery, smooth UI?
The secret is simple, really. Minimize the work the main thread has to do.
Because it's busy running JavaScript, handling input.
All of that.
Yeah.
And if your animation depends on the main thread, it's going to stutter the second that thread gets blocked.
So S-tier must bypass the main thread entirely.
Exactly.
Yeah.
S-tier animations use compositor thread properties. You have to stick to things like transform, opacity, and filter.
Right.
So those are handled by the browser's graphics card, so they run smoothly even if your JavaScript's going crazy.
Yeah.
The second you introduce expensive stuff like repainting or layout recalculation,
You're in C-tier or D-tier.
you're in trouble.
Yeah. And efficiency isn't just about the browser, it's the language we use. As a developer, I am genuinely excited by one of the newer features in TypeScript. The satisfies keyword.
It's brilliant, isn't it?
It sounds so niche, but it solves a huge daily pain point.
It absolutely does.
Yeah.
And it's such a clever piece of language design. Before satisfies, you had to choose. Do I strictly type my object to make sure it conforms? Or do I let TypeScript infer the specific and literal type, which you need for things like autocomplete?
You had to trade safety for convenience.
You did. But satisfies acts as a type-safe cast. It makes sure the assignment fits the required type, but it still lets TypeScript infer the most specific type from the value itself. You get both perfect enforcement and that precise value-based inference.
The best of both worlds.
It's a perfect balance.
And happy developers ship better code faster, which is why we're seeing new tools like Outcrop emerge, a faster, simpler alternative to Confluence, built in Rust, just to improve that internal documentation experience. But all of this human productivity kind of pales in comparison to what's next, the rise of the machine coworker.
The shift to agentic models is without a doubt the dominant story in engineering right now. And we have to talk about Claude Opus 4.5 from Anthropic.
What makes this model such a leap?
Its performance across technical domains is. It's just stunning. Independent data shows it's the best model in the world right now for complex tasks involving coding, agents, and computer use. It's outperforming human candidates in technical skills assessments.
So this isn't just a better chatbot.
No, not at all. This is genuinely capable digital collaborator for real engineering tasks.
And Anthropic is pushing this even further with new beta features for tool use. They have a tool search tool, which lets Claude dynamically discover and load tools on the fly.
Right, which reduces context window overhead. And then there's Programmatic Tool Calling,
where Claude can actually orchestrate multiple tools by executing code. It's writing its own workflow.
And this whole trend is confirming what some people call the bitter lesson of LLM extensions.
Okay, what's that?
The idea that early attempts at complex, rigid API integrations, like the first ChatGPT plugins, were just too brittle. The models weren't smart enough to handle ambiguity. The successful approach, which we're seeing now, is to give the agent general-purpose tools with simple, natural language instructions.
You let the model's intelligence figure out the complex orchestration. It's a different way of thinking. You almost have to be a vocal technologist, right? You're speaking to the machine to get the job done.
Exactly. But that tremendous leap in capability, it comes with an equally immense security cost.
The dark side is emerging faster than we can secure it.
Absolutely. The attack vector is changing. We saw a perfect and terrifying example with the indirect prompt injection attack called Google Anti-Gravity.
Okay, break that down for us. How does an attacker actually use an AI to steal data?
So the attack showed how an attacker could poison a file, something that was totally harmless, inside a project. When a user who is using the Gemini AI in their code editor interacts with that file, the poisoned data manipulates the AI assistant itself.
How?
The attacker's code tricked the AI into using a browser subagent to build a crafted URL. This URL then exfiltrated sensitive data code snippets, credentials from the user's workspace, completely bypassing file access protections.
So the AI became the unwitting data thief.
That's it. It became the thief. which is deeply unsettling because it means the AI itself is the vector. And we're pairing this new tech with a very human weakness: the code review bottleneck for senior engineers.
Right. The AI is generating code at an incredible velocity.
And it's completely overwhelming the review process. Senior engineers, the only people really qualified to catch these subtle security flaws in edge cases, are facing a deluge of AI-generated code. They just can't keep up.
The speed of the machine is challenging the quality control of the human.
That's the tension right there.
And speaking of risk and quality control, let's pivot back to the foundation of the web. What keeps it all running, or what makes it fail?
The recent widespread Cloudflare outage was a perfect and painful lesson in systemic fragility.
And it wasn't a DDoS attack or hardware failure. It was a config and application logic flaw hitting a database change.
Right, and the result was, massive disruption.
You've argued this outage was, in a strange way, a good thing. Why?
It's a strange thing to say, but yeah. In a sense, it was. Because it was this violent reminder of the dangers of internet centralization. Just like 2020 forced the world to think about diversifying physical supply chains.
This should push businesses to diversify their infrastructure?
I think it has to. And more critically, the core failure wasn't about physical redundancy. It was a failure to prioritize logical data correctness and robust database design.
And that brings us to that fundamental database debate: eventual consistency versus strong consistency.
Which is an eternal debate. But eventual consistency, where data takes time to propagate, it just causes so much pain for application developers. They have to constantly build workarounds for when the data they read is temporarily wrong. It just leads to bugs.
So how does strong consistency solve that pain?
Well, solutions like Aurora DSQL are designed to ensure that storage replicas only return data for a specific timestamp once they have definitively seen all updates up to that point.
No more reading stale data.
You avoid those nasty intermediate states. It fundamentally simplifies application development and removes a major source of bugs. It's an investment in resilience through correctness.
And we're seeing similar efforts to strengthen the weakest link in modern software. The open source supply chain, there's a new tool, SafeNPM.
This is a brilliant proactive mechanism. It's designed to defend against supply chain attacks, which are becoming frighteningly common.
So when a bad actor pushes a poisoned version of a popular package,
they rely on developers immediately pulling that version into their build process.
Okay, so what's the countermeasure?
SafeNPM works by querying the NPM registry and only installing package versions that have been publicly available for a minimum time. The default is 90 days.
So it filters out anything brand new.
Exactly. It creates this crucial 3-month buffer that lets security researchers and the community identify and flag poisoned packages before they ever get into your pipeline. It's preventative engineering.
It's smart, simple defense. Okay, so if we step back and pull all these threads together, we've got these immense productivity gains from agentic AI like Opus 4.5.
But those gains are being directly challenged by these complex, subtle security risks like anti-gravity and the enduring need for simple, robust infrastructure. Strong data consistency, supply chain vigilance. The tension is at an all-time high.
And we also have to think about platform ownership. Who controls the tools we rely on? This is where it gets really interesting. The Zig programming language project made a strategic decision to migrate its main repository from GitHub to Codeberg.
Yeah, and this was a deliberate, principle-driven move. They cited concerns about GitHub's engineering decline and, critically, their push for proprietary AI features that violated the Zig project's policies.
So it's a pushback against vendor lock-in.
It's a huge pushback. It highlights this growing, healthy movement among developers to support non-profit decentralized platforms. It's a really key indicator of where platform loyalty stands right now.
Right.
So where does this all leave you, the future builder, as you try to navigate this? I mean, if our biggest development tools are now AI models that thrive on ambiguity, that often default to proprietary black boxes, how long until the very concept of reliable, deterministic code becomes the bottleneck, not the solution?
That's a deep question.
And if the new generation of engineers, the vibe coders, are being defaulted to these frameworks by AI tools, how will we effectively teach and champion vanilla web platform capabilities to prevent a future where the entire web is just built on a handful of opaque AI-mandated stacks? It's a crucial question to mull over until our next conversation.
Spoken Tech, for your ears.